the plane of polarized light to clockwise direction is known as the dextrorotatory or plus isomer, right student? Now the second type of optical active compound, Laevorotatory. Laevorotatory or minus isomer. Now student, what is the Laevorotatory or minus isomer? This is a compound which rotates the plane of polarized light to left hand side, or we can say anti-clockwise direction. Okay? It can rotate. These are the compounds which can rotate the plane of polarized light to anti-clockwise direction, or we can say left hand side. Right students? So such isomers which can rotate the plane of polarized light to anti-clockwise direction or left hand side, such isomers are known as Laevorotatory or minus isomers, right? While dextrorotatory or plus isomers, they can rotate the plane of polarized light to clockwise direction or right hand side. Now students, we will see some example to understand the concept. First of all, we will see the optical isomerism in lactic acid, right? Optical isomerism in lactic acid, and we will discuss the optical isomers of lactic acid. Optical isomerism in lactic acid. Optical isomerism in lactic acid. Dear students, what is lactic acid? We know very well lactic acid is found in milk, right? And its IUPAC name is 2-hydroxypropanoic acid. 2-hydroxypropanoic acid. If we write the structure of lactic acid, then its structure would be like this. Now students, how many carbon atoms are there? We count the number of carbon atoms. Do the numbering first of all. This is 1, 2, 3. Right students? Now, what is the position of hydroxyl group in this compound? Hydroxyl group is attached with second carbon. So that's why it is 2-hydroxy. 2-hydroxy, right? And since carboxylic group is there, so this is basically carboxylic acid, right students? How many carbon atoms are there? 1, 2, 3. So its name is started with prop. E of N is replaced by oic acid, right? So what is the name of this molecule students? It is, the IUPAC name of this molecule is 2-hydroxypropanoic acid. Propanoic acid, right students? 2-hydroxypropanoic acid. Now, this compound exists in two isomeric forms. We have two optical isomers of lactic acid, right? This is the one form, right? And the another form of lactic acid is This is again 2-hydroxypropanoic acid. 1, 2, 3. The position of hydroxyl group is same. Both these forms of propanoic acid, they are mirror images of each other. They are mirror images of each other. Like here, if you place a mirror here, mirror. Both these forms are mirror images of each other. Both these forms are optical active form, right? This form of lactic acid, where at the second carbon, hydroxyl group is present on the right hand side. Hydroxyl group is present in this carbon here. You can notice, students, what is the position of hydroxyl group? It is present on right hand side, right? While in this form, here in this form, you can notice at second carbon, hydroxyl group is present on left hand side. Hydroxyl group is present on left hand side, right? This form is dextrorotatory. Dextrorotatory, or we can write this form as the plus form, plus isomer, or you can say this is plus acid, right? And this form in which hydroxyl group is present on left hand side. Hydroxyl group is present on left hand side. This is the Laevorotatory form, or we can write as minus acid. Plus shows this form of 2-hydroxypropanoic acid or lactic acid rotate the plane of polarized light to right hand side or to clockwise direction, right, students? And it is optical active compound. Similarly, here minus acid, minus shows this is the Laevorotatory form of lactic acid. It can rotate the plane of polarized light to left hand side, right, students? And both these forms are optical active and they are mirror images of each other. Optical active and mirror images of each other. So mirror images of these optical active compounds, they are known as enantiomers. They are enantiomers. We use a new term, enantiomer. What is enantiomer, students? Enantiomer, enantiomers. What is enantiomer? Enantiomers are known superimposable mirror images. These are known superimposable mirror images. Mirror images. Known superimposable mirror images, they are known as enantiomers, right? It means, what is meant by superimposable, students? You can notice here, if you place both hands over here, thumb of right hand face the thumb of left hand. Likewise, these two fingers can place over each other, right? So this form is known as a superimposable, right? But if we see the mirror image of left hand, the mirror image of left hand is not another left hand, but the mirror image of left hand is a right hand, right? Like this way, we can place a right hand over left hand. So the mirror image of left hand is not another left hand, but it is a right hand. Now let's see another example of optical isomers. We will see the optical isomerism in another optical isomer, that is tartaric acid. Optical isomerism in tartaric acid. tartaric acid is usually found, tartaric acid. First of all, we know what is tartaric acid, students. Its IUPAC name is 2,3-dihydroxybutane dioic acid, right? Let's see the structure of tartaric acid. What should be the structure of tartaric acid? Here we write its structure. 1, 2, we have 2 carbons. Here we have a carboxylic group, and with carbon number 1, here we have another carboxylic group, right? In between the carbons, at this carbon we have hydrogen atom on right hand side, hydroxyl group on left hand side, right? And with second carbon, here we have hydroxyl group on right hand side while hydrogen atom on left hand side. How many carbon atoms are there, students? 1, 2, 3, 4, right? At the second carbon we have hydroxyl group, as well as at the third carbon we have hydroxyl group. So how many hydroxyl groups are there? We have 2 hydroxyl groups. So that's why it is dihydroxy, right? So how can we write its name? What are the position of hydroxyl group, students? One hydroxyl group is present at carbon number 2, another is present at carbon number 3. So we can write 2,3-dihydroxy. How many total number of carbon atoms are there? 1, 2, 3, 4. 4 carbon alkane is known as butane, right? So it is 2,3-dihydroxybutane. And since it contains 2 carboxylic groups are there, so that's why we will write dioic acid. This is the IUPAC name of this molecule, that is 2,3-dihydroxybutane dioic acid. Commonly it is known as tartaric acid. Right, students? Now we will write this form of tartaric acid, at which at the third carbon we have hydroxyl group on left hand side, and at the second carbon we have hydroxyl group on right hand side, right? This form of tartaric acid is dextrorotatory form, or this is the plus acid. Dextrorotatory form or plus acid. It means it can rotate the plane of polarized light to clockwise direction, to right hand side, right, students? Now if we will write the second form of tartaric acid. The second form of tartaric acid will be written like this. We place 4 carbon atoms like COOH attached with this carbon, again another carbon, and here we have COOH group. Now here we have hydroxyl group on right hand side, and here we have hydroxyl group on left hand side, right, students? Now on the opposite direction we made hydrogen atoms. Again we do the numbering. 1, 2, 3, 4. This is 2,3-dihydroxybutane dioic acid or tartaric acid. This is tartaric acid, students. But here in this form of tartaric acid, you can notice at carbon number 2 hydroxyl group is present on left hand side, while at carbon number 3 hydroxyl group is present on right hand side, right, students? So both these forms, that is, this is the plus isomer or dextrorotatory form, while this is minus acid or minus isomer, that is, this form is levorotatory. This form of tartaric acid is levorotatory. It means it can rotate the plane of polarized light to left hand side, right, students? Both these forms are mirror images of each other. Like here, if we place a mirror here, both these forms are mirror images of each other. Since these are mirror images of each other, so we can say they are enantiomers. right students. Now we have another form of tartaric acid.